All right, in this lesson here, we're going to be talking about 7.3, which is trig functions and the unit circle. So again, it has a lot of assumptions that you know all this information already, but the goal is to already know the unit circle. So let's go ahead and I'm going to quickly go through a lesson of how to build a unit circle. We've already discussed a unit. This is a horrible circle. Let's try that again. Let me start from this direction. Man, telling you what, making a circle is hard. All right, well, that's fine. That's close enough. All right, so this is a unit circle. And again, we know it's a unit circle because these are all 1 unit long. All right. And so with that, you kind of already know a few things. All right, this right here is when we talk about degrees, would be 0 degrees. This would be 0 degrees. This would be 90 degrees because it's a quarter of a circle. This would be 180 degrees because it would be half of a circle. This would be 270 degrees because it's 3/4 of a circle, and then it comes back to a full circle at 360. Half of a quarter here would be 45 degrees, and then half of this way here would be 135 degrees. And all we did is do 90 plus 45. If we add another 45 to 180, we get 225. If we get 45 plus the 270, we get 315. After this point, we have these knowns as 30. Then this would be 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So those are all the angle measurements for degrees. You then need to also know their radiant measures. So 0 degrees would be 0 radians. It's the best way to do this. This would then be 2 pi for a full circle. We know that already. Half of a circle would put us at just a pi. Half of a circle would put us at pi of a half. Half of a half of a half will give us pi fourths. So if we take this, would be pi fourths, 2 pi fourths, which is pi halves. This would become 3 pi fourths. This would then become 4 pi fourths, which is just pi. This is then 5 pi fourths, 6 pi fourths, which is actually 3 pi halves. This would be 7 pi fourths. And then this would be 8 pi fourths, which is just 2 pi. We also learned in 7.1 that 30 degrees is the same thing as pi 6. So if we keep this pattern going, this would be pi 6. This would be 2 pi 6, which is pi thirds. And then this would be 3 pi 6, which is pi halves. This would then be 4 pi 6, which is 2 pi thirds. This would then be 5 pi 6. This would be 6 pi 6, which is just pi. This would then be 7 pi 6. This would then be 8 pi 6, which is 4 pi thirds. This would then be 9 pi thirds, which is actually 3 halves. No, 9 pi 6, which would be 3 halves. This would then be 10 pi 6, which is 5 pi thirds. This would then be 11 pi thirds. Nope, 11 pi sixths. And then this would be 12 pi 6, which is back to 2 pi. So there's all your degrees and all your radians. Best way to start is start here and then kind of go all the way around to help you memorize them all. After that point, because this right here is at 1, this coordinate is 0, or sorry, 0, 1 comma 0. This right here would be 0 comma 1. this would be -1, comma 0. This would be 0, -1. Now, from that, there's three fractions that you have to know. You have to have the square root of 2 over 2 memorized. And the square root 2 over 2 will always be with the square root of 2 over 2 because this point right here is the same distance from the x and the y-axis, so they have the same coordinate. After that, you need to memorize what your signs are. This is positive, positive. This is negative, positive. So this one here would be negative square root of 2 over 2, comma, square root 2 over 2. This one here is negative, negative. So this would be negative square root of 2 over 2, comma, negative square root of 2 over 2. This is positive, negative. So then this one would be square root of 2 over 2, comma, negative square root of 2 over 2. After this point, the other two fractions you need to know is the square root of 3 over 2 and 1/2. So just three fractions to memorize. Now, to know which one goes where, square root 3 over 2 is bigger than 1/2. So if I'm closer to the x-axis than I am the y-axis, then the x value would get the larger number. Vice versa, if I'm closer to the y value, the y value would get the larger number. Once you have that concept grasped, then you can know where their sign changes are. So I'm closer to the y, so this would be 1/2, and then, oh, sorry, negative 1/2, because the side's negative, and then this would be the square root of 3 over 2. This here, I'm closer to the x, so this is now negative square root of 3 over 2 and 1/2. This guy right here, again, I'm closer to the x, so that would be negative square root 3 over 2, comma, negative 1/2. Notice this time they're both the same. And yeah, make sure I got that. And then this one here, I'm closer to the y, so this would be negative 1/2, negative square root 3 over 2. I'm closer to the y, so again, I would get closer to the y, this would be positive 1/2, negative square root 3 over 2, because again, this is positive, negative. This one over here then would become square root 3 over 2 and negative 1/2. We need to know these coordinates. So if you can memorize one quadrant, you can know the rest depending on their signs. We need to know this because our x comma y coordinates are written as cosine theta, sine theta. So if you are asked, like in the earlier lecture in 7.2, we need to know what sine of pi fourths was. Well, here's pi fourths. Sine's the y value, so I know my answer is just a square root 2 over 2. This is that memorization part, because once we have this, we can answer a lot of questions. So again, this is everything that they expect you to already know about the unit circle, so make sure you build your own, use it as a guide, but try to avoid using it and have it more memorized. All right. All right. With that said, in this unit or in this lesson, they talk about the extending of the domain of the inverse function. So domain of the inverse function. And the issue they talk about it with regular trig functions, cosine and sine trig functions are all real numbers. There is no gaps in the domain. The issue is if cosine theta, so if, let's try this again. If cosine theta equals 0, then that would mean that secant of theta would equal 1 over 0 because it's the inverse. But you can't have 1 over 0, so it's undefined. So secant does not have an answer if cosine is equal to 0. Same concept. If we have sine theta equal to 0, that would mean cosecant of theta is 1 over 0, which again would be undefined. So if sine's equal to 0, cosecant doesn't have an answer. Same concept with tangent. If tangent's equal to 0, cotangent would be undefined. All right. So then another interpretation of SOHCAHTOA, and I don't usually follow it too much because it's the same thing as SOHCAHTOA. But if this is our theta, this would be the opposite. This is the hypotenuse. This is the adjacent. But this is also known as the x. This is also known as the y, and this is also known as the r. So you can have different formulas, and you can have sine theta instead of opposite over hypotenuse. It'd be the same thing as y over r. Cosine of theta, instead of it being adjacent over hypotenuse, it could be your x over r. Tan theta is equal to opposite over adjacent, which would just be y over x. And then the inverses go the same way. So cosecant theta could just be r over y. Secant theta is just r over x. And cotangent theta is x over y. So that's another way to interpret the same thing as SOHCAHTOA. The next thing it teaches you is what we have called is reference angles, which is be labeled as theta with a little dash above it. So what that means is if I have an angle in the first quadrant, let's call this theta, the reference angle is equal to theta, right? The reference angle is basically the angle from the x-axis to what we call the terminant side. So this is called the terminant side. There we go. And so then same concept, if I have an angle in the second quadrant, and here's my theta, this would be my reference angle. Same concept, if I have a angle in the third quadrant, here's my third quadrant. This right here would be my reference angle. And then last one, if I had it in the fourth quadrant, then this right here will be considered my reference angle. All right. So a reference angle is going to always be between 0 and 90 or 0 and pi halves, depending on if you're talking about radians or degrees. All right. In this section as well, we then start getting into identities, which will then kind of line us up for some proofs. So we have our co-function identities. And these are things they expect you to have memorized. So cosine theta is equal to sine of pi halves minus theta. So if you know what theta is, it's going to be the same answer as if it's pi halves minus theta for sine. And then same concept with cosecant theta. It's going to be secant pi halves minus theta. So if you know if you're trying to look for cosecant of an answer, you could do secant pi halves minus that answer and get the exact same conclusion. We also have cotangent of theta, and that would be equal to tangent of pi halves minus theta. You also have to know your reciprocal identities, which we've already talked about, I believe, in the 7.1, but cosecant of theta is the same thing as 1 over sine theta. Secant of theta is the same thing as 1 over cosine theta. And cotangent of theta is equal to 1 over tan theta. You then need to know your quotient identities, which is tan theta is equal to sine theta over cosine theta. This is a little bit easier to remember if you remember that it's y over x, and that you remember that x is cosine and sine is y. And then cotangent is just the inverse of that. So that's cosine theta over sine theta, which again is the same concept as x over y. All right, so those are your first three sets of identities they expect you to have memorized. And then we'll kind of progressively get further and further with those as we move on. So that's pretty much the gist of the entire 7.3. So let's get into some examples that you would see in your homework. Let's look at number 1. It says determine the point xy on the unit circle associated with the real number s. So I'm looking for the coordinate when s equals pi 6. So again, using the unit circle, that's this value right here. So the goal is to try to remember it. Pi 6 is the same thing as 30 degrees and is closer to the x-axis. So